So example 1a, we have the log of xy over z with a base of 5. And what we're going to do is we're going to rewrite this logarithm so that x, y, and z all have an exponent of 1 and are all in their own logarithm. Okay? So the first thing that I'm going to do is I'm going to just point out to you that in the numerator here, we have a product of two arguments. And we also have a fraction where we have a numerator and a denominator being divided. Okay? So the first thing that I'm going to do is I'm going to take this fraction and use the second law, this one right here, that we just looked at. I'm going to split my logarithm into the log of the numerator minus the log of the denominator. Okay, so it's going to look like this. This becomes the log of xy, my numerator, with a base of 5, minus the log of just z, my denominator. Okay, so that's just following this law that I had previously, right? The top becomes the first logarithm, the bottom becomes the second logarithm, and both of them have the same base. Okay, the next thing I'm going to do, can you see it? It's one more split. I'm going to split this, right? How am I going to split this? Yeah, according to the first law up here, whenever I'm multiplying two things in a logarithm, I can split it into two separate logarithms where each of those logarithms are added together with the same base. So I'm going to take log x, y base 5 and write it as log x base 5 plus log y base 5 minus still log z base 5. B is still on that page, it's just to the right. B says the log of the cube roots of x with a base of 7. And I want to rewrite this so that the x term has an exponent of 1. Okay? Let me just ask you from the start here, what's another way to write a cube root? Could you write a cube root with an exponent? Maybe that's a better way of saying it. Tobias?
Power of 1 over 3.
Yeah, to the power of 1 over 3. Right? I can write this radical as a power. I could just raise x to the power of 1 over 3. 1 is the exponent of that x, 3 is the root. Right? So this is the same thing as going the log of x to the 1 over 3 with a base of 7. Now my argument inside of my logarithm has an exponent. What can I do with that exponent? Think about law number 3 that we looked at. Let's see that law again. That was this one here. What could I do with exponents? Where can I move them to? Yeah, they can become coefficients of the entire logarithm. So I can take that 1 over 3 exponent and move it in front of the entire logarithm. So I have log x base 7, and that's as far as I can go. Again, my goal was to make sure that x had an exponent of 1, and now it does. Okay, let's do another one here. Let's try C, which says the log of 1 over x squared base 6. And we want to rewrite that so that x has an exponent of positive 1. Any ideas for what we could do?
The second identity thing again, or the second equation. Try to split that.
You want to split it? We could do that. There's actually a way we could rewrite this so that it's one single logarithm. Because the way you're thinking right now, it would split it into 2. Mm-hmm. Maybe just think, could I write 1 over x squared as just x to the power of something?
X to the power of 1 over 2.
X to the power of negative 2.
Negative 2.
Right? If I wrote x to the power of negative 2, that's the same thing as going 1 over x squared, right?
Right.
So that's what I'm going to do. So I'm going to go log x to the negative 2 base 6. And then what do I do with that exponent?
And use the third.
Yeah, use the third law. Where does it go?
Front of the equation.
It goes in front. So it becomes the coefficient. Negative log x base 6, and that's as far as we can go. Again, my goal was to make sure that this exponent of x was just 1.